Okay, dear students, good morning to all of you.
Morning,
Uh,
sir.
Good morning. Um, I'm recording this video. Okay, so if Google Meet ask any concern, then just kindly press yes. Okay, uh, if it asks, okay, then only. So till now we have just started the introduction part, okay, of thermodynamics, and I think you have come to know about what is thermodynamics. Okay, just today I will recapitulate, okay, what we have studied till now, and before that I want to say about the quiz, okay, which most of you have submitted. Okay, so I have gone through those answers. Okay, though there may be some doubts maybe in your mind, so I think today it will be clear to you. Okay, so we will just again discuss those topics with examples. So let me present, okay, uh, with PPT presentation. Yeah. So yes. So here I have prepared one presentation, okay, to give you the insight of the topics of this module one of thermodynamics. So first of all, we should know the proper definition, okay, of this thermodynamics. So the thermodynamics, actually it is the axiomatic branch which deals with the relation among heat, work and properties of system and which are in equilibrium. So this is one axiomatic branch. So axiomatic branch means it is self-evident. So all the happenings in the thermodynamics can be experienced. Okay, so we don't need to create any hypothesis, we don't need to create any proof. Okay, as because it is experienced and self-evident, so this is called as axiomatic branch of science, and it deals with basically heat and work. Okay, and here the properties of the systems are studied. So when the systems are in equilibrium, okay, when the systems are considered in equilibrium. So the application of thermodynamics. So yesterday also I have told you that the application of thermodynamics, the laws, governing laws, can be seen in steam and nuclear power plants. So where the electricity is generated, then internal combustion engines. Internal combustion engines means the engines where the fuel is burned. Okay, just like your motor car engine where petrol or diesel are burned and produce the power. Okay, and that power is transmitted to the axle and the vehicle moves forward, isn't it? So the basic laws which are inside the engine, it is governed by thermodynamic laws. Then gas turbines, air conditioning. Okay, so air conditioning, you are having one subject, refrigeration and air conditioning. It is in 8th semester of your mechanical engineering. So there you will come to know what are the applications, okay, application part of this thermodynamics. So in our syllabus, so just we will see some cycles, okay, governing cycles, thermodynamic cycles by which these ACs, okay, the AC split AC, all of you know, all of you are having maybe. Okay, so how these ACs actually work, okay, on which principle. So these things are the applications of the governing laws of thermodynamics. Okay, then refrigeration, same thing, refrigeration and air conditioning. Gas dynamics, jet propulsion. Okay, compressors. So compressors are the device, okay, uh, to compress. Okay, I think someone wants to join. So these are the mechanical devices by which the air, okay, or the gas, whatever it is, or the fluid, it is compressed, okay, to high pressure. So those are called as compressors, okay. Then chemical process plants. So all these things are governed by the laws of thermodynamics, okay. Then when we study the thermodynamics, so basically there are two approaches. So one is macroscopic approach, another is the microscopic approach, okay, or viewpoint. So what is macroscopic approach? It is also called as classical thermodynamics. So in this approach, a certain quantity of matter is considered without the events occurring at the microscopic level being taken into account. Suppose there is one glass of water. So we will apply the classical thermodynamics or macroscopic approach. So we will not study in the molecular level, okay. So we will study the property of the system by considering some average value, okay. We will not go to the molecular level, atomic level. So that concept or that approach is called as macroscopic approach, okay. So macroscopic thermodynamics is only concerned with the effects of many molecules, and these effects can be perceived by human senses, okay. So we can sense these effects because those are macroscopic, okay, not microscopic. For example, the macroscopic quantity pressure, okay. So pressure, what do you mean by pressure? So it is the average rate of change of momentum due to molecular collisions of all the molecules. So on a particular area, okay, on one unit area, what are the collisions of average particles? So that is defined as pressure, okay. But here in macroscopic approach, so we will define the pressure as average pressure, okay. So that is the classical thermodynamics. So whatever we are going to study here in your syllabus, these are classical thermodynamics or macroscopic approach, okay, on the basis of macroscopic approach. There is other approach, that is microscopic approach or statistical thermodynamics. So microscopic approach means what? So we will study each and every molecule, okay, or every molecule, and we will find out the properties. It is the approach. The matter is composed of myriads of molecules. So if it is a gas, each molecule at given instant has a certain position, velocity, and energy, okay, each molecule. And for each molecule, these change very frequently as a result of collision, okay. So just like the rocket technology, okay. So if you can give the example of rocket technology. So in rocket technology, so we need to analyze each and every nature of the particle, okay, or the molecule, so that the velocity, so that the energy, okay, whatever properties, that can be thoroughly understood, okay, so that there is no problem, okay, in launching the rocket or in traveling the rocket. Two approaches are used. So example of these microscopic approach can be seen in highly rarefied gases, okay, highly rarefied gases, rocket technology, then spacecraft technology. So in all those, this microscopic approach or statistical thermodynamics is used, okay. So now the concept of continuum, okay. So this concept of continuum is basically one idealization of the continuous description of matter, where the properties of matter are considered as continuous function of space variable, okay. So one glass of water, so we will consider it continue, okay. The molecules, the properties of the molecules are considered as continuous function of space variables, okay. So one of the factors considered important in determining the validity of continuum model is molecular density. Okay, so this molecular density is the distance between the molecule, which is characterized by mean free path. Okay, mean free path, it is denoted by lambda. Actually, there is one number which is known as Knudsen number. Okay, Knudsen number. So it is the ratio between the mean free path lambda by capital L, characteristic length, lambda by capital L. This characteristic length of any object is find out by dividing the volume by area. Okay, then you will get this characteristic length capital L. So Knudsen number equals to lambda by capital L. And when this Knudsen number exceeds a value of 0.01, then the concept of continuum does not hold good. So we will not say that the matter or the substance or the system holds concept of continuum. So when it exceeds a value of 0.01, so you should remember these 2-3 points. Okay, so this molecular density is characterized by mean free path. It is denoted by lambda. Okay, here it is not written, it is denoted by lambda. And when the Knudsen number values it crosses 0.01, then the concept of continuum does not hold good. Okay, so these two things are very important. Okay, for objective questions. Yeah. Now let's come to the main two things, that is system, thermodynamic system, and it is also called sometimes as control volume. So where it is called as control volume, I will tell you. So the thermodynamic system, it is basically one small part of universe. Okay, so universe is huge. Okay, it is very large. So it is one small part of universe which we will apply the laws of thermodynamics to the system, and that subset of that universe is called as the system. Okay, or you can define in other way, that anything which is taken under observation, which is a subset of the universe and which is separated from the universe by a boundary, is called a system. So that way also you can define a system. Okay, a system may be anything: one compressor, one boiler, one IC engine, the human body, your room, your classroom. Okay, anything. So where you are applying the thermodynamic laws and you are analyzing the system, so that is the system. This system is separated from the universe by a boundary. Okay, and the system boundary, it can be a real system boundary or one imaginary system boundary. Sometimes we will imagine the system boundary by considering some particular area or volume. Okay, so rest of the portion of the universe is called a surrounding. Okay, so system plus surrounding will compose the universe. Okay, so the system is of basically three types. So first one is the closed system, or it is called as closed mass system, because to have a system, so it should have mass. Okay, it should have mass. That system which is closed, that is, this is closed mass system, or it is called as closed system. Okay, so we will call it as closed system mainly. Okay, the second system is the control volume system or open system. Okay, so this control volume term, so we have seen in the system, this control volume system or the open system. Okay, and the third system is the isolated system. Okay, so isolated system. So what is a closed system then? So basically the system is separated from the surrounding by a boundary. So if through this boundary the transfer of matter, okay, or transfer of energy can happen. So if in a system energy can interact, but there is no mass transfer to the system from the surrounding. No mass can enter to the system, or from the system no mass can goes out to the surrounding. Then if we analyze that system, so that system is called as closed system. So here the figure depicts that thing, that energy can interact and the system can interact with the surrounding by transferring energy, okay, but there is no mass transfer of the system to the surrounding, or to the surrounding to the system. So these kind of systems are called as closed system. Okay, so you can give the example of the system, closed system, as pressure cooker. Okay, you can say the example of pressure cooker. So in pressure cooker, so you can heat from the gas burner, okay, but no mass will come out. Okay, so initially no mass comes out, but when the boiling point is reached, then some mass comes out. So that is different thing. But up to the whistling of the pressure cooker, so that system is called as closed system. Okay, then your balloon, gas balloons. Okay, so that gas balloons, the gas may be heated because the balloon surface is very thin surface, so heat can comes out or goes in, okay, from the surrounding. So that system will be a closed system. Okay, then you can take the example of, suppose one gas, okay, or one fluid is confined in a piston cylinder arrangement. Okay, so that piston may be heated. If that is a metallic piston, then that can be heated, so heat can be felt, okay, inside the gas. Or if you just put one thermometer, then the temperature of the gas or the fluid will increase, isn't it? So you can see it. So that kind of system where the energy can interact, okay, or heat can interact, energy can interact, that kind of system is called as a closed system, but there is no mass transfer. Okay, so now let's come to the other type of system, that is open system. Okay, these open systems are called as control volume systems. So here the energy can comes in and comes out, the mass can also interact through the system. Okay, so these type of systems are called as open system. So the air compressor, okay, air compressor, the pump, electric pump or water pump. So in water pump, what happens from the tank, okay, or from the water supply? So water just comes in, okay, and it is delivered, okay, to the destination. So masses are coming out and going, coming in and going out, okay, but there is a confined mass in the pump. Okay, so if we analyze the pump, so we will only concentrating our study on that particular volume where the mass is accumulated. Okay, so we will not be concentrating the outer parts of that pump, electric pump, okay, where the fluid is coming and it is going out. Okay, in the confined volume, so whatever fluid, okay, or gas, whatever it is accumulated, so that thing, that things property, that properties will be studied. Okay, so that is an open system. I think now it is clear to you. Then boiler, compressor, IC engines, all these are the examples of this open system. Okay, you should remember these examples because then only your ideas of open system, okay, or the closed systems will be clear to you. Okay, so next one is the isolated system. Okay, so isolated system means there will not be any mass transfer, there will not be any energy transfer. Okay, the whole universe is of that kind. Okay, the total energy, whatever it is confined in that particular universe space only. Okay, so no mass is going out, okay, no mass is coming in. Okay, or no energies are going out, no energy is going, means coming in. Okay, whatever it is there, it is remain the same. Okay, so that universe is a isolated system, you can say. Then thermoflux, so I have told you about this example, thermoflux. So there is an insulation on the outer cover of the flux, so no energy can interact from the surrounding or from the system to the surrounding, and no mass can come in or goes out. So this is one example, okay, of this isolated system. So control volume, so actually this control volume is the open system. Okay, so here it is shown separately how the air compressor. Okay, here there is a air compressor. So I have told you that air will come in, okay, and air will goes out. But here in this confined space, okay, and this is the imaginary boundary. I have told you that the boundaries may be fixed boundary, okay, or the boundaries may be imaginary boundary. Okay, so inside this boundary, this air compressor, it is analyzed. Okay, so this is an open system. Now let's come to some terminologies, okay, which are very much important for you to remember, okay, throughout your life, because now you are in the core part of the mechanical engineering, isn't it? So first one is the thermodynamic properties. So what do you mean by property actually? So properties are the entities through which the state, okay, state of a system is defined. Okay, state of a system is defined. So what do you mean by state? So it is the nature of the system. Okay, so suppose water is in freezing condition, okay, means it is in ice, so that is that ice condition is a state. Then solid is one of kind of state of a system. So states of matter, so basically there are 4 states of matter, okay, but here we will study only 3 states of matter. Okay, one is solid, liquid and gas. So plasma state we will not study here, okay, under this course. So what are the thermodynamic properties? So these properties are macroscopic in nature. Okay, so as we are studying the macroscopic approach or the classical approach, so that is why these properties of the thermodynamics will be macroscopic in nature. Means the pressure, suppose pressure is one property, volume is one property. So pressure is what? So pressure is force per unit area. Okay, or the molecular collision. So as we have defined, okay, so average molecular collisions on a particular area. Okay, so average molecular collisions means what? Some forces it will apply on a particular area, so that is defined as the pressure. Okay, so these properties will define the state of the system. Okay, so here it is written that properties are the coordinates to describe the state of a system. So any operation in which one or more of the properties of a system changes, it is called change of state. So if the temperature is changed, okay, so as I have told you that the temperature, if water is raised to 100 degrees centigrade, so it will be there will be one change of state. Okay, means from liquid the water will convert to gas. Okay, just like that, the freezing temperature 0 degree centigrade, okay, at 1 atmospheric pressure, the water will be converted to ice, liquid will be converted to ice. So there is a change of state of the system. Okay, so these properties, okay, so properties of the system may be classified into 2 broad categories. So one is the intensive properties. Okay, these properties, pressure, temperature, volume, density, enthalpy, entropy. Okay, so all these things, properties can be categorized into 2 category. One is intensive property, another is extensive property. Okay, so what is intensive property? See, to remember this definition, intensive. So in is there, so independent. So the systems, the properties which are independent, the properties which are independent of the mass, okay, of the system are called as intensive. The IN term is there, so independent of mass. And extensive properties, these are not independent of mass. So the properties which are independent of the mass are called as intensive property, and the properties which are not independent of mass, means dependent of mass, those are called as extensive property of the system. So here it is written, so which are the intensive property? Pressure. Okay, so independent of mass. So for a small vessel also, the pressure may be 1 bar. Okay, and for the bigger room also, okay, where you are staying, the pressure may be of 1 bar. Okay, so here the extent of matter doesn't depend. Okay, means mass of the system does not depend. Okay, means does not influence the property of the system. Means pressure is not influenced by mass of the system. For let us consider for 1000 molecules, whatever may be the pressure, for 10 lakhs molecules also that pressure may be there. Okay, so pressure is independent of quantity of matter. Okay, then the temperature. So the temperature of our room, okay, the room maybe it is 25 degrees centigrade, or let's say 30 degrees centigrade. The outside a large number of meters are there, large number of mass is there, isn't it? So the temperature does not depend, okay, on the mass of the system. So it is also an intensive property, independent of mass. Then concentration, density, okay. Suppose salt is there in a small container, so whatever may be the density for a in a okay, in a bucket, if the pool of bucket is of salt, then also the density may be same. Okay, so the density property, it doesn't depend on the mass of the system. Concentration, then melting point, boiling point. For 10 ml of water, the boiling point, okay, it doesn't depend on the mass. Okay, so for 100 milliliter of water, 100 liter of water also, so the boiling point may be same. Okay, so it doesn't depend on mass. Then surface tension, viscosity. So all these things are, all these properties are intensive property. It does not depend on the mass of the system. Okay, then extensive property. So I have told you these extensive properties are influenced by the mass of the system. If you change the mass, okay, of the system, the property will automatically change. So mass, okay, mass is also extensive properties. Volume, okay, so volume. Suppose yeah, the volume is also influenced by the mass. Okay, so dependent on mass. Then internal energy, heat capacity. Okay, so if you increase the mass of a system, the internal energy will vary. If you increase the mass of the system, okay, mass of a system, suppose earlier it was x, now it is x plus y, then volume will change. Okay, then heat capacity, enthalpy, entropy. So all these things you need to remember. Okay, so these properties uh, are dependent on mass. These 8 properties, here it is listed as 8, but it may be more. Okay, so you need to find out what are the properties which are independent of mass and what are dependent of mass. Okay, so I think these things are clear to you. Okay, so today, so I will stop here. So up to this much, whatever we have just studied, so you need to study yourself. Okay, so here I will be sharing these PPTs. Okay, part by part I will be sharing this. I will be sharing the video. Okay, I have recorded it. So I will be sharing it in Google Classroom. So you just you can have the okay, access. You can access this video. Okay, so dear student, uh, so as because the syllabus is little bit bigger, okay, we have got many contents for the first module and the second module, so we will move little bit faster. Okay, this theory part we will move little bit faster, and for the derivation part, so I will try to derive. Okay, so in class, okay, by on paper by the use of pen or sketch pen, whatever it is, so that you can grab the concept well. Okay, so thank you dear students for listening. So if you have any,
Thank you, sir.
yeah, if you have anything to ask, then you can ask. Okay, I am giving you 2-3 minutes. So if you have any doubt or if you have any queries, then you can ask. Yes.
No doubt, sir.
I think you don't have any queries. Okay, then yeah,
Yes.
you can leave this meeting. We will meet in the next meeting. Okay, and I will share some information. Okay, in the Google in our WhatsApp group. So time to time. Okay, you just check your WhatsApp group. Okay, thank you so
Okay,
much.
thank you, sir.
Yeah,
Thank you.
thank you.